So, you click a link, you load a video, you send a message, it all feels instant, right? Like magic. But behind that screen, your data is going on an incredible journey. It's not a straight line from your computer to, say, Google's servers. Instead, it's a road trip. Your information is hopping from one computer to another, crossing cities, countries, and even oceans in milliseconds. It's a complex, invisible highway system that makes the modern internet work. And most of the time that highway is clear and everything is super fast. But what happens when it's not? What happens when a web page takes forever to load, or your online game starts lagging out of nowhere? You might blame your Wi-Fi, and sometimes that's the case. But often the problem isn't in your house. It's somewhere out there on that digital highway. There could be a slowdown, a traffic jam, or a closed road at one of the many stops along the way. Wouldn't it be cool if you could see the exact route your data is taking and pinpoint where the delay is happening? This is where a super useful but often overlooked tool comes into play. It's like having a GPS tracker for your data packets. Imagine you sent a package, and you could see every single post office it stopped at on its way to its destination. You could see how long it spent at each stop, and the full path it took to get there. Knowing this path is incredibly powerful for troubleshooting. It helps you understand if the problem is with your own internet connection, the website's server, or one of the many steps in between. It takes the guesswork out of why is this so slow. Knowing the path is step one. This knowledge transforms you from a passive user into someone who can actually diagnose what's going on under the hood. It's a fundamental piece of the puzzle for anyone curious about how the internet actually works beyond the browser window. It's one of those classic tech tools that has been around forever because it's so simple and so effective. It gives you a level of transparency that is rare in our polished, seamless digital world. So let's pull back the curtain and look at the tool that makes this all possible. So what is this tool? It's called Traceroute. Or on Windows you might see it as Tracert, but they both do the same thing. Think of it as a diagnostic command built right into your computer's operating system. You don't need to download anything special to use it. It's been a standard utility for decades. Its job is simple: to trace the route, or the path, that your data takes from your device to any destination on the internet. It shows you every single hop along that journey. So what's a hop? Let's use an analogy. Imagine you're sending a series of letters to a friend across the country. But instead of sending one letter, you send 30 of them, one after another. Your first letter has a special instruction: return to sender after you reach the first post office. The post office receives it, sends it back to you, and you record how long that took. Now you know the location of the first stop, and how fast the connection is to it. It's a simple, clever way to map the very beginning of the journey. Next, you send the second letter. This one has a different instruction: return to sender after you reach the second post office. That letter travels to the first stop, then gets forwarded to the second, which then sends it back to you. Now, you know the location of the second hop, and the time it took to get there. You're basically building a map, one stop at a time, by sending out these special packets with an increasing time to live, or TTL. It's a brilliant process of elimination. You repeat this process for the third letter, the fourth, and so on, each time telling it to go one hop further before returning. Traceroute does this automatically, sending out packets of data and carefully recording each stop that sends a "Hey, I'm here" message back. Each of these stops is a router, a specialized computer whose job is to direct internet traffic. By the end, you have a complete step-by-step list of every router your data passed through to reach its final destination, plus the time it took for each round trip. It's a full itinerary for your data's road trip. Alright, so how do you actually use this thing? It's easier than you think. You don't need fancy software, just your computer's command line interface. On a Mac or Linux, this is called the terminal. On a Windows PC, it's the command prompt or PowerShell. Just search for it in your applications and open it up. You'll see a black or white window with a blinking cursor. Don't be intimidated. This is where you can talk directly to your computer's operating system. It's a powerful and direct way to get things done. Once you have the terminal open, you just type in the command. On a Mac or Linux, you'll type Traceroute followed by the website or IP address you want to check. For example, to trace the path to Google, you would type traceroute.google.com and hit enter. On a Windows machine, the command is slightly different. You'll type traceroute.google.com and press enter. That's it. The computer will immediately start the process, sending out those packets and mapping the journey for you. The results will start appearing line by line. Each numbered line represents one hop on the journey. So, Line 1 is the first router your data hits, which is probably your own router at home. Line 2 is the next step, likely your internet service provider's equipment down the street. You'll see the name of the router if it's available, its IP address, and then 3 time measurements. These times, measured in milliseconds, show how long it took for 3 separate test packets to make the round trip to that specific hop and back. So what are you looking for in these results? Consistency is key. You want to see low, stable times for each hop. If you see a sudden jump in time, for example from 20 milliseconds to 200 milliseconds, that indicates a potential bottleneck at that point in the network. If you see asterisks instead of times, it means the packet timed out and didn't get a response. A few asterisks are normal, as some routers are configured not to reply, but if you see a whole line of them, followed by more timeouts, you've likely found where the connection is breaking down. Now that you know how to run a Traceroute and read the results, you can start using it for practical troubleshooting. Let's say your favorite streaming service is buffering constantly. Run a Traceroute to its domain, like TracerouteNetflix.com. Watch the results. If the first few hops have high times, the problem might be with your local network or your ISP. But if the first several hops are fast and then you hit a slow hop deep in the list, the issue is likely with the network closer to the service's servers, completely out of your control. Here's another tip: run Traceroute multiple times. The internet is dynamic. Routes can change. Running the command a few times over several minutes can give you a better average and help you confirm if a slowdown is consistent or just a temporary hiccup. Also, try tracing to different major websites like Google, Cloudflare, 1.1.1.1, or your favorite news site. This helps you figure out if the problem is specific to one destination or if it's a more general issue affecting all your internet traffic. It's all about gathering clues to solve the mystery. Traceroute is just one tool in a massive world of networking diagnostics, but it's a fantastic starting point. It empowers you to look beyond the surface and understand the structure of the internet in a tangible way. It's a classic for a reason. Getting comfortable with tools like this is the first step toward a deeper appreciation for the technology we use every single day. Don't be afraid to experiment. You can't break anything by running a Traceroute, so open up that terminal and see where your data goes. So I encourage you to give it a try. The next time something feels slow online, don't just reset your router and hope for the best. Pop open that terminal, run a Traceroute, and see what you can find. It's a small step that can teach you a ton, and if you're into learning more about the tech that powers our world, definitely stick around. We're always diving into stuff like this, so if you found this helpful, you know the drill. Like, subscribe, and hit that bell so you don't miss the next one.